Hello everyone. The focus of today's webinar will be on Shimadzu's solution for THC quantitation and how it is important to the forensic science community. My name is Rachel Lieberman, and I'm the current marketing manager for forensics here at Shimadzu Scientific Instruments. My contact information is listed below. The Farm Bill of 2014 distinguished hemp from marijuana. However, the language was vague and it was difficult to interpret the law. This led the federal U.S. government to pass the Hemp Farming Act in December 2018, which legalized the cultivation and distribution of hemp at the federal level. So what does this mean for seized material and law enforcement? Well, marijuana is still a Scheduled I drug by DEA guidelines, so quantification of suspected material for THC must be done. And in the text of this act, it states that in order for a plant to be considered hemp, a plant must contain no more than 0.3% THC on a dry weight basis. In addition, this allows for hemp and hemp products to be moved across state lines, no matter if they have medicinal or recreational laws already in place. The passing of the Farm Bill has been all over the news. Here are a few articles stating the difficulties that law enforcement is facing with the initial passing of the bill. Shimadzu offers many different options for THC quantitation. These analytical techniques utilize existing equipment from the laboratory, but also might include new instrumentation, depending on the level of confidence that is required for each case. Our solutions are GC-FID with our GC2030 and GCMS with our GC-QP2020NX system. Furthermore, we can move to our LC-UV or LC-PDA with our integrated L-series and LCMS with our LCMS 2020 single quadrupole. We will discuss each of these techniques further. Here's a chromatogram for a cannabis product run by GC-FID. We see a large peak for THC just after 14 minutes and can easily separate and identify many cannabinoids, especially THC, in under 16 minutes. Furthermore, if we run this analysis using GCMS, we can get mass confirmation for each peak and similarity scores using library searching. The benefits of GC-FID and GCMS analysis is the low cost in comparison to its chromatography cousin, LC and LCMS. Here we show an 11 cannabinoid standard mix run in under 6 minutes. However, there are some limitations to using GC or GCMS for THC quantitation. All the acid forms, THCA, CBDA, etc., are converted to delta-9 THC or CBD during the injection process. This means that one can only measure total THC content using this technique. One could derivatize the THC acid or acid forms so it does not convert, but that takes time and can be costly. So we recommend using HPLC-UV or PDA for confirmation quantification of all THC components. This integrated system is low cost, easy to use, has validated methods, a service protection plan, and most of all, gives full separation of delta-9 THC, delta-8 THC, and THC acid without derivatization. This is called either the Cannabis or Hemp Analyzer. It does not matter which product you choose, the components are the same, it is just that the marketing is different. This analyzer package comes with all the standards, solvents, columns that would be needed, as well as 3 different methods and a simplified overlay software for ease of use. Let's go into some details about the methods that are provided. Here's a chromatogram for the high-throughput method. This method determines the 10 most common cannabinoids in just under 8 minutes. The high-resolution method analyzes 11 cannabinoids with full baseline resolution, but with a longer analysis time of under 30 minutes. This adds THCV as the 11th component. The high-sensitivity method includes THCV as well and can analyze 11 cannabinoids in under 10 minutes. This is the method that we recommend for THC quantitation for forensic community. In addition, we have developed a method for 16 cannabinoids using UHPLC-PDA in just under 5 minutes. By utilizing UHPLC, The peaks are sharper, and the analysis is completed in a shorter amount of time. Here we show a chromatogram of a real flower sample. The standards are shown in black, and the flower sample is in magenta. One can see two large peaks for THCA and delta-9 THC. No delta-8 THC was present in this sample. If delta-8 THC is seen, it is typically in vape cartridges and/or oil samples. Here's a chromatogram of a raw oil sample. Since this sample is extracted as opposed to the flower, we see a much larger delta-9 THC peak. We have also done some work with more complex sample matrices, such as gummy bears. In this study, we spiked the sample with the standards and wanted to look at the recovery rates for each cannabinoid. The recoveries of the gummy bear sample were all above 90%, with THCA and delta-9 THC both above 95%. Here's some data showing how well the analyzer works with commercial hemp oil samples. What is interesting to note is that the top oil was well refined and had a relatively clean chromatogram, with only a 0.06% amount of THC measured. The bottom hemp oil still had a value less than 0.3% THC, but the sample matrix was much dirtier, as evidenced by the image and chromatogram. This was completed with the standard method that comes with our analyzer. If a customer is interested in upgrading to the 3D or PDA version of the Cannabis Analyzer, we can take advantage of the iPDeA software function specific to Shimadzu products. This software function allows for slightly overlapping peaks, such as structurally similar cannabinoids, as shown here, to be represented as individual peaks. The middle image shows separation of the 5 cannabinoids between 1.5 and 2 minutes. The bottom image shows 2 representative peaks for delta-9 and delta-8 THC. This allows for more accurate quantitation of THC content by providing peak identification in the form of retention time, spectral confirmation by PDA, and mass matching, if a mass spec were to be included. Here's a printout of the quantitative results from the analyzer. Each analyte is identified by their retention time, and based off the dilution factor and weight of the sample, the software is able to report the dry weight percent of each cannabinoid. Then, the total THC and CBD content can be reported. In this example, the sample had 5.2% total THC. So far, we have discussed GC, GCMS, and LC techniques. According to SWIG drug categories of analytical techniques, the minimum recommendations includes one technique from category A and another from either category B or C. If a category A technique is not used, 2 techniques from B must be used. When using HPLC-UV or LC-PDA, it is possible this could not meet the minimum standard. So to be safe, we could add a mass spec to the technique, and it will satisfy the minimum recommendations. As quoted from SWIG drug section 3B.4, these recommendations are minimum standards for the forensic identification of common seized drugs. However, it should be recognized that they may not be sufficient for the identification of all drugs in all circumstances. End quote. This is where our LCMS 2020 single quadrupole would easily be added to the end of the Cannabis Analyzer. This would allow for further confirmation of delta-9, delta-8, and THC acid forms. One would get additional MS information, which provides more confident results for court and allows for additional internal standard. In addition, our LCMS 2020 single quadrupole has ultra-fast scanning speed of 15,000 AMU per second, which allows for SIM and scan runs at the same time without the loss of efficiency. This adds another layer of mass spec identification to the quantitation of THC. Here is a chromatogram using the LCMS single quad for a 16 cannabinoid mix in positive mode. Delta-9 and delta-8 THC are both baseline resolved, and the analysis time is just under 11 minutes. Here are the acid forms present in the mix that are all ionized using negative mode. Both positive and negative mode are run simultaneously with a 15 millisecond polarity switch between them. So, in conclusion, Shimadzu offers many different solutions for THC quantitation, depending on the level of budget and confidence that the analyst needs. GC and GCMS analysis only gives total THC content and will require longer runs and derivatization. Our Cannabis or Hemp Analyzer provides separation of all the cannabinoids without derivatization and comes standard with all the components that you would need to quantitate THC. And to further enhance your analysis, one could add our LCMS 2020 single quadrupole for MS confirmation, which helps with more complex sample matrices and provides more sensitivity than PDA or UV detection. Thank you for your attention today. If you have additional questions, please go to investigateyourlab.com, or for additional cannabis solution questions, growyourlab.com.